Welcome to A-Level and AP Physics. In today's lesson, we will discuss some important and tricky questions from June 2022 Paper 1 Variant 2. In this lesson, we will discuss some challenging questions in detail so you can have better understanding of these questions and you can improve your conceptual understanding of these topics. Let's study together, let's improve together. In today's lesson, we will discuss question number 5, question number 8, question number 22, 23, 26 and 37. These are the most difficult questions from this paper because most of the candidates, they were not able to answer these questions correctly in the exam. So we will discuss these questions in detail so you can have better understanding of these questions and also you can improve your conceptual understanding of these topics. This is one of the best way to improve your understanding of these topics. If you solve difficult question, you will face challenge and you will improve yourself when you will understand that concept in detail. So this is one of the best way to improve your conceptual understanding, or simply we can say is the best way to improve your understanding of physics. So we will focus only on these 6 questions in today's class. The best way to get maximum benefit from this video is pause the video, do these questions first of all by yourself, and then compare your answers with my answers and check the solution to improve your understanding. For question number 5, it is given to us: a car travels anti-clockwise along a horizontal circular road of radius 12 meters as shown in the figure. The car takes a time of 4.0 seconds to move from position P to position Q. What is the magnitude of the average velocity of the car for the journey from P to Q? Question is asking us to calculate average velocity. So we need to understand how we can calculate V average. Average velocity is equal to total displacement, not total distance. If you use total distance, it means you will calculate average speed. In this case, average speed and average velocity are different because it is not moving in a straight line. If the car is moving in a straight line, in that case, magnitude of average velocity and magnitude of average speed will be the same. But in this case, car is not moving in a straight line, so the average speed and magnitude of average velocity will be different. So we need to calculate average velocity. So we need to take total displacement divided by total time taken. So very important point you need to understand. For the velocity, you need to take total displacement divided by total time taken from P to Q, total time. In this case, we need to find out total displacement. Total displacement is simply the straight line joining P to Q. So we need to find out this, and this is the total displacement. In this case, you can see we have a right angle triangle. So this side is the hypotenuse of triangle, and we can simply say this is D. So D in this case will be equal to 12 square plus 12 square and root of this one. So this one is the total displacement. So simply we can plug in this value. So this is 12 square plus we have this is 12 square root of this divided by total time taken, and total time taken in this case is 4 seconds. So simply we can divide by 4 seconds. Now if we solve this one, our answer for this question will be equal to 4.2 meters per second. So the correct option for this question is A. So A is the right answer. Most of the students did wrong in this case because they just get confused with average velocity and average speed. They used here total distance divided by total time and they got answer D, and D is the wrong answer. This is average speed, not average velocity. So the average velocity is equal to 4.2 meters per second, and this is right answer. For question number 8, it is given to us: a child of mass 20 kilograms stands on the rough surface of a sledge of mass 40 kilograms. The sledge can slide on a horizontal frictionless surface. One end of a rope is attached to the sledge. The rope passes around a fixed frictionless pole, and the other end of the rope is held by the child as shown in figure. The rope is horizontal. The child pulls on the rope with a horizontal force of 12 newtons. This causes the child and the sledge to move with equal acceleration towards the pole. We need to find out what is the frictional force between the child and the sledge. This question is very nice question on mechanics, or simply we can say is a great question on forces. Let's try to answer this one step by step. For this question, it is given to us the child pulls on the rope with a horizontal force of 12 newtons. Mean this child is pulling this rope to the left with a force of 12 newtons. Now we need to consider tension in the rope. So if this boy is pulling this rope to the left with a force of 12 newtons, there will be reaction force that will be acting to the right, then this one will be equal to 12 newtons. Now we need to understand, as this is the same string, so it means the tension in the string is the same. And now if we take sledge as our object, so how much force is acting on the sledge? Force acting on the sledge also will be equal to 12 newtons. Now we can consider this sledge and this boy as one system. We can place them in one box, so this is our one system. Now we need to understand total force acting on this system. In this case, the total force acting on this system is equal to 24 newtons. We can also draw like this. So this is sledge and boy, so we have sledge and boys inside. Total force acting on this system is equal to 24 newtons, 12 newtons and 12 newtons. From here we can find out acceleration of the system. In order to find acceleration of the system, we can simply say A is equal to F net divided by total mass of the system, M system. Total force, net force we have, that is equal to 24 newtons, and mass of the system is 40 plus 20. 20 is the mass of the child. So if we solve this one, we can find out value of acceleration of this system. Acceleration in this case will be equal to 0.4 meters per second per second. So this is value of acceleration. We need to find out the frictional force acting between the child and the sledge. Now we need to take boy, for example, as one object. If you look at the boy, there are two forces, so simply imagine that this one is the boy. The force acting on the boy to the right is 12 newtons. As this boy has tendency to move to the right relative to the sledge, there will be friction acting on this boy to the left, so this one is friction. Now we have acceleration of the boy and we have force acting on the boy only, so we can find out the frictional force. So the net force we can write down will be equal to 12 minus F. This one has to be equal to mass of the child, so this is mass of the child time acceleration. Mass of the child is 20 kilogram and acceleration is 0.4, so we can find out value of F. F in this case will be equal to 12 minus 20 times 0.4, and we can find out our final answer. Final answer in this case will be equal to 4.0 newtons. So this is the force of friction acting between child and the sled, and force of friction on boy and child is the same. So the answer for this question is A. Now let's try to answer this question by considering forces acting on the sledge only. You can imagine that this one is the sledge. We have already discussed the force acting on the sledge to the right is 12 newton, and this is tension force in the string. Now we need to understand what is direction of frictional force acting on the sledge. We have already discussed the frictional force acting on the child is to the left. If the frictional force acting on the child is to the left, because child has tendency to go to the right, so sledge will have tendency to go to the left, and the frictional force acting on this sledge has to be to the right. Now we understand forces acting on the sledge. So we can use F is equal to ma and we can find out value of friction because we have value of acceleration of the system. Acceleration of the system was equal to 0.4 meters per second per second. So simply we can write down in this case F net has to be equal to ma. F net in this case is equal to 12 plus F, and this is equal to mass of the sledge, that is equal to 40 kilograms, and acceleration is 0.4. Now simply we can solve this one for F. So we can write down F is equal to 40 times 0.4 minus 12. And if we solve this one, our answer will be 16 minus 12, and value of the friction force will be equal to 4.0 newtons. So the final answer again will be equal to 4 newtons. So the answer is A. We can also find acceleration by considering forces on the child and the sledge. Let's try to understand a different way to find acceleration. We can simply sketch in this case. This is the sledge and here we have the child. Child is standing inside this sledge. We have discussed the force acting on the child, in this case to the right, is 12 newtons, and the force of friction acting on the child is to the left. So this is the force of friction acting on the child, and this is to the left. And force acting on the sledge to the right, this is equal to 12 newtons, and force of friction acting on the sledge is to the right. So this is the force of friction acting on the sledge. Now we can use this one and we can write down two equations. For the child we can write down 12 minus F, this is equal to 20 times A. And for the sledge we can write down 12 plus F because forces are in the same directions, and this is equal to 40A. From here, by adding these two equations, we can cancel F with F. So here we will get, this is 24, 12 plus 12, and here we have 68. So we can find out value of A. A from here will be equal to 0.4 meters per second per second. And now we have value of A, and we can use any equation from here. We can use equation 1 or we can use equation 2, and we can find out value of friction as we have done before. So this is another way to find value of acceleration. You can write down the equations and then you can solve them and you can find out value of A. If you have value of A, then you can find value of F. Very nice question on mechanics. If you have any questions, you need more explanations, so please just leave your questions in comments. Before I go to next question, let me explain you a little bit more about this one. When you are talking about the child, you need to consider only forces acting on the child, not forces acting by the child. So when we draw free body diagram, we talk about forces acting on that object. Mean forces acting on the child or forces acting on the sledge. Very important concept. Let me ask you one more question. So this is very important one. Imagine that we have one big box and there is one small box that is placed at the top of this. Now in this case, if I apply force on this big box, let's say I apply force F. In this case, this big box, it has tendency to go to the right. But this box, if you look at this box, if there is no force acting on this box has tendency to go to the left. So the force of friction on this box has to be to the right. And the force of friction on this big box, it has to be to the left. Because this block has tendency to go back, so the force of friction on this one will be to the right. And this box has tendency to go to the right, and force of friction on this one has to be to the left. So very important concept, and this is the concept we have used to find the force of friction on the child. As there is a force acting on the child to the right, so child has tendency to go to the right. So force of friction on the child is to the left. And opposite is true for the sledge. Sledge has tendency to go to the left, So the force of friction on the sledge is to the right. So this is the main concept you need to understand how to approach this type of problem. And this is very nice question to understand how forces and how friction acts on two different objects. For question number 22, it is given to us a transverse water wave is moving along the surface of some water. This causes a ball to move vertically without moving horizontally as it floats upon the surface. At one instant, the ball is at the position shown in the figure. The wave has a frequency of 0.20 Hz and amplitude of 0.70 meters. The distance between a trough and adjacent peak is 2.4 meters. We need to find out what is the distance traveled by the ball in a time of 20 seconds. For this question, amplitude of the wave is given. So this is very important one. Amplitude of the wave is given to us. And also frequency of the wave is given. We need to find out the total distance traveled by this ball in a time of 20 seconds. So first of all, we need to understand how this ball will travel. When this ball will travel from this point to here, distance traveled by this ball will be equal to 0.70 meters, mean equal to 1 amplitude. And then this ball will go to the bottom, means will go to the lowest point at this point. Again, it will travel 0.70 meters. And then this ball will start moving up and it will reach at equilibrium again. So the distance traveled in this case also will be equal to 1 amplitude, 0.70 meters. And then it will come back to the same position. So simply we can draw the ball here. Distance traveled will be equal to 0.70 meters. So in one cycle, distance traveled in one cycle we can write down. Distance traveled in one cycle. Distance traveled in one cycle. That distance will be equal to 4 times 0.70 meters. Now if we can calculate number of cycles, so we can calculate the total distance. So we can also write down in this case total distance travel will be equal to number of cycle, let's say n is the number of cycles, time the distance travel in one cycle, that is 4 times 0.70 meters. So simply we need to find out value of n, number of cycles. In order to find number of cycles, we can take the total time taken divided by time period. So we can find out number of cycles. Total time in this case is given to us. That time is equal to 20 seconds. Now we need to find out time period. And time period is equal to 1 over frequency. Time period is equal to 1 over frequency, and frequency is given to us, that is equal to 0.20 Hertz. So we can replace this one with 1 over f. So we can write down 1 over f, or simply we can say 20 seconds time frequency. So we have time frequency. So we have 20, we can multiply with frequency, that is equal to 0.20. So we can simplify this. So we have 20 multiplied by 0.20, and we can find out the number of cycles. In this case, number of cycles will be equal to 4. So we have number of cycles that is equal to 4. We need to find out the total distance travel. Total distance travel. So we can write down here total distance travel. Total distance traveled. Total distance traveled will be equal to n times 4 times 0.70. This is the distance traveled in one cycle. So this is distance traveled in one cycle, and we can multiply with number of cycles. 4 times 0.70. So the final answer in this case will be equal to 11.2 meters. So the answer for this question is C. C is the right answer. So simply you need to understand, question is asking you total distance travel, so you can calculate distance traveled in one cycle and then you can multiply that with number of cycles to calculate total distance traveled. And distance traveled by particle in one cycle is equal to 4 times amplitude. So you can find the total distance. So this is how you can approach this problem. Try to understand concept, not just try to understand this question. Try to get the concept from this question. The concept is your takeaway. If you just understand how to do this problem, but you don't improve your conceptual understanding, it means no use of this question. From this question, you need to take away concepts and how to apply this concept next time to answer other questions. So that is the best way how you can improve yourself. For this question, it is given to us a sound wave travels from left to right across a room. The variation with distance across the room of the displacement of the air molecules at one instant is shown. We need to find out at which distance air pressure will be the lowest. Air pressure will be lowest at rarefaction. Rarefaction simply means that particles are moving away from each other. And compression means that particles are getting closer. They are moving towards each other like this. Particles are moving towards each other. So here P will be the lowest, mean pressure will be lower, and at compression pressure will be the highest. If we have understanding of this, now we can look at this given displacement graph. So in this case, these particles, the displacement is positive, means from 0 to A displacement is positive. It means particles are moving to the right. And between B and D, displacement is negative, means particles are moving to the left. So at point B, there is compression. So at point B, there is compression, means the P here will be the greatest. Now if you look at point D, these particles, they have negative displacement, they're moving to the left, and particle here, they're moving to the right. So at this point there will be rarefaction. So here is rarefaction. It simply means that value of P will be the lowest. And question is asking us to find the distance where value of P is the lowest. So the P is lowest at point D. So D is the answer for this question. Very straightforward question if your concept is clear. First thing you need to understand, what is rarefaction, what is compression, and how to find from displacement against distance graph. So displacement positive, particles moving to the right. Displacement negative, particles are moving to the left. So we can find this one is compression and this is rarefaction because particles are moving away from each other. So the answer for this question is D. For question number 26, it is given to us two polarizing filters are placed next to each other so that their planes are parallel. The first polarizing filter has its transmission axis at an angle of 50 degrees to the vertical. The second polarizing filter has its transmission axis at an angle of 20 degrees to the vertical. The angle between the transmission axis of the two polarizing filters is 30 degrees. A beam of vertically polarized light of intensity 8.0 watts per square meter is incident normally on the first polarizing filter. What is the intensity of the light that is transmitted from the second polarizing filter? Very nice question on polarization. If your concept is clear, this question is pretty straightforward one. If your concept is not clear, this is very tricky one. A lot of angles are given to you. You need to understand how to deal with given angles. First of all, it is given to us the beam is vertically polarized. So simply we can sketch. The best way to answer this problem is by sketching. So you can see the picture. Vertically polarized light. So this one is vertically polarized light. Let's say intensity of this light is I naught. This light passes through a polarizing filter, and transmission axis of the polarizing filter is given. Transmission axis is at angle of 50 degrees with vertical. So this angle is given to us. This angle is 50 degrees. Now the light, after passing through this one, let's say the intensity of the light is I1, and then it is given to us there is an other polarizing filter that is at an angle of 20 degrees to the vertical. So this one is at angle of 20 degrees to the vertical, means angle of transmission axis with vertical, this angle is 20 degrees. And let's say the intensity of light after this filter is I2, and we need to find out value of I2. Let's try to find out first of all I1. In order to find I1, we need to understand I transmitted. So this is the formula you need to understand. I transmitted. This one will be equal to I incident. So we can write down here I incident time cosine square theta, means the angle between transmission axis. So this is the angle between transmission axis. Angle between transmission axis. Angle between. So very important point. Angle between transmission axis. Transmission axis. Angle between. So very important one. Now if you look at the first one, so in this case I1 will be equal to I naught time cosine of 50 degrees, mean cosine square of 50 degrees, because the angle between this and transmission axis is 50 degrees. Now if we need to find out I2, we will simply say this is equal to I1 time cosine of angle between transmission axis. Now if we draw this transmission axis here, so let me use different color, you can see that we have this first transmission axis. This is at angle of 50 degrees to the vertical. And what is the angle between these two? This angle is 50 degrees. So what is the angle between these two? This angle is 30 degrees. So we have to take cosine of 30 degrees. Angle between transmission axis and square of this. Now we can plug in value of I1. I1 is equal to I naught. But I naught is given, that is equal to 8. So we can simply write down 8.0 cosine square, cosine of 50 degrees and square of that, cosine square of 50 degrees. So here we can write down I1, this is 8.0. We have cosine square 50 degrees and we have cosine square of 30 degrees. And now if we solve this, we will get our final value of I2 is equal to 2.5 watts per square meter. So the answer for this question is B. Only tricky part was you need to understand theta is the angle between transmission axis. So you have to take 30 degrees, not 20 degrees. So this is the tricky part. You have to be clear about this. So the answer for this question is B. B is the right answer. For question number 37, it is given to us a potentiometer circuit is used to determine the electromotive force EX of a cell. The circuit includes a second cell of non-EMF E0 and negligible internal resistance. A uniform resistance wire PQ of known length. EX is less than E0. The movable connection J can be positioned anywhere along the length of the resistance wire. Which circuit is suitable for determining EX? So in order to answer this question, we have to check all these circuits one by one and we need to find the suitable circuit. Let's try to find out the best possible circuit. if you look at circuit A, in this case you can see the positive terminal of E0 is not connected with positive terminal of EX. It simply means that in this case we cannot find the balance point. Balance point simply means when reading on galvanometer is equal to 0. So that is not possible. So it means we cannot use this circuit to find EMF of cell X. Now if you look at circuit B, in this case you can see galvanometer, it is connected with E0, but it has to be connected with EX. So in this case we can also not find the balance point. So galvanometer is connected wrong way. So this option is also not possible. Now if you look at option C, in this case you can also see galvanometer is connected here. This is connected in series with E0, or simply you can say this one is the driver cell. But galvanometer has to be connected in series with X. So it means this is connected in a wrong way. So in this case also we cannot find balance point. So option C is also not possible circuit to find EMF of cell X. Now if you look at option D, or you can say circuit D, in this case galvanometer is connected in series with X. This is right. And the positive terminal of X is connected with positive terminal of E0. So this circuit is suitable circuit to find value of EMF of cell X. So our answer for this question is D. So you need to understand galvanometer has to be connected with X, and also it has to be connected in series, and positive terminal of two cells, they have to be connected with each other. Means we have positive terminal of X here, it has to be connected with positive terminal of E0. So simply you can see from here. So this is, they have to be connected like this. So this circuit is the suitable one. So the answer for this one is D.